Hey everyone, this is Prateek, and today I'm going to talk about how you can detect anti patterns in software code using machine learning. I'm a software engineer, and oftentimes when I'm writing code, there are certain patterns or structures of the code that causes detrimental experience when it comes to software development. These are actually anti-patterns. They are ineffective redundant sections in software code that impacts code readability, performance, and can also cause potential bugs and errors. Now, why do we want to use ML to solve the problem? As already told, anti-patterns cause code to be error prone. They uh, also affect the readability and understanding of the code. There are oftentimes redundant sections in software code that might cause exceptions or errors during execution. Uh, Manually, it might be difficult to detect anti patterns. Oftentimes, software engineers don't have the in depth understanding of what they are, and they don't have the knowledge. Also, it is tedious to sift through uh, large sections of the code to detect anti-patterns, and uh, code readability is adversely affected with anti-patterns. So it becomes difficult to read the code to detect them in the first place. Machine learning, it can be used to learn from standalone pieces of code certain anti-patterns, and they can be employed to detect these anti-patterns and remediate them in an effective and expedited manner. The problem definition, so we intend to design a system that detects three major anti-patterns in code. God class is an anti-pattern where there might be one class which tries to control too many other objects, and so it becomes a class that does everything. Cyclomatic complexity, that occurs when there are too many branches or loops inside the code. And shotgun surgery, it's a feature or it's an anti-pattern where a single code change requires changes in multiple places. So who are our target users? Our target users are software engineers and software development managers. Why does it matter? It matters because uh, anti-patterns, as already told, they affect code readability, they cause errors and exceptions when it comes to enhancement of the code, making it difficult to maintain and debug the code. Currently, uh, a lot of anti-patterns go undetected. Sometimes they would be addressed if they cause cascading errors or bugs, and some anti-patterns are detected in manual code review process. What is the expected impact? The expected impact is to design a system which detects and remediates anti-patterns in an automated manner. Uh, the outcome would be reduction in software development time, debugging time, uh, and the output can be measured in terms of precision and recall computed from a confusion based matrix based on how effectively and accurately this system detects these anti patterns. Uh, we want to detect at least 70% of these anti patterns uh, in the software code. The constraints is that we are limiting the scope to only three specific anti patterns. What are the relevant factors? They would differ based on the kind of anti pattern that you want to detect. For God class, it would the proportion of the functions that are implemented by the class, the number of child classes would matter. For cyclomatic complexity, the number of if else conditions or the branches inside a certain section of the code. For shotgun surgery, number of lines of code that requires to be changed when we want to change one single line uh, is of relevance. Assumption is that we we need a code parser that can effectively parse the code to give us the classes, the functions, the dependencies of the class, the number of places a function is called, and the number of branches in a function. So we would assume that we can use one of the existing parsers that exist in the industry. We also need to have access to the verbose error logs, and also the history of code changes made in code repositories. Now, what is the hypothesis of the solution validation plan? Now, there are no clear definitions of anti-patterns. Oftentimes, these are user-defined and they are very relevant to the users who are writing or using the code. So, we intend to develop this system based on a clustering and a classification approach. First, we would identify the code repositories that we would use to train our model. We will derive certain code snippets from there. Then we would use the parser to extract characteristics from these code snippets like branches, child classes, function calls, number of dependencies. We would also use the logs to get some external characteristics like the number of places errors, the number of places or the places where the errors are being thrown. What are these errors? We would get the user input regarding the quality and the readability of the code, the time taken for them to understand the code. Uh, Based on these characteristics, we would cluster the code into different clusters. We would further take user input as well as domain expertise to come up with a loose set of heuristic rules uh, to label these code snippets with uh, anti-patterns uh, if they are symptomatic of certain anti-patterns. So once the labeling is done, we would use this label data to create a classification model that would classify a code snippet to one of these three anti-patterns or none of them based on the characteristics of the code snippet. What are the experiments conducted for this solution plan? We would need to collect the data. So we would collect this data at different stages. We would identify the code repositories. We would then identify the code snippets within these repositories that we will use for uh, training and clustering. We would use a parser to extract these relevant features from these code snippets. We would use logs to collect error and bug fix details. We would identify the users and we would get input from them regarding the code quality, their readability, their understanding of the code. And we would also get the input from domain experts for labeling these clusters or code snippets after they have been clustered. Uh, we would first create a mockup or a model that uses a clustering algorithm to cluster a certain code snippet. Then we would take a small code snippet and we would test out how this model clusters this code snippet. After some experimentation, we will actually build a clustering model to cluster different code snippets. After these clusters are formed, we will, with the help of user input and domain expertise, come up with a set of loosely come up with a loose set of heuristic rules to label this data. For example, we can say that if the number of branch statements in a function is uh, in a function is 70% of the number of lines of the code, then we can say that that code is cyclomatically complex. So after these code snippets are clustered and labeled, we would use these label data to build a classification model to detect any incoming code snippet to one of the three anti-patterns or none if that code does not have any anti-patterns in them. Uh, so after this model is created, we will deploy it, we will observe it in action, we will identify a set of testers who can test these code snippets for anti-patterns. And as I said, since it is very specific to user input, we would need to collect user feedback and we would use this feedback to further fine-tune the model. We will use the feedback to recalibrate what other features might be relevant, repeat the data collection, and then further retrain and fine-tune the model. What are the various aspects of design? Cloud versus edge. So it's going to be a hybrid model. Users would be able to submit code links to the code repositories or upload files in the cloud to detect anti-patterns, but they would also be able to use this software as a plugin or in their local development machines to detect anti-patterns. It can be used as a plugin in their editor to even detect anti-patterns in real time. Offline versus online, we will uh, adopt an offline mode of training. We will first identify the code repositories, download the data from them, and then train the model in an offline fashion. Batch versus online prediction, we will design this system as an online prediction system. Uh, it should be able to detect anti-patterns in real time when a plugin is installed in an editor, or within a certain frame of time when a request is actually raised for detecting anti-patterns in a certain pull request or uh, a merge request. What are some of the potential risks? Code repositories that can be tested, they vary in volume, coding style. Different users come with different coding philosophies. They write code differently, and they might have different notions of what anti-patterns are. It can be tricky to even incorporate the user feedback or train a model for a specific set of users. Uh, Latency, we don't really see any risks for latency as it's going to be a hybrid model. Data drift, uh, there is considerable chances of data drift because software development is a field that changes rapidly over a period of time. There are new coding styles, new programming constructs that evolve over time, and as a result of this, the heuristic rules that we had initially used to label the data which was used for training the model might not be true after a certain time. So we need to incorporate this newly evolving and changing coding paradigms, styles, programming languages uh, uh, to retrain our model uh, in order to ensure that it accurately detects the anti-patterns. Concept drift, there is no foreseeable risks of concept drift unless, like, at certain stage some of this characteristics of anti-patterns becomes desirable in some future programming language or paradigms. So yeah, yeah, that's it for now. Thank you.